Section 7 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For information or to volunteer, please visit LibriVox.org. Recording by Gary Gilbert, 2007. Familiar Letters on Chemistry by Justus Liebig. Letter 7. My dear Sir, the source of animal heat, its laws, and the influence it exerts upon the functions of the animal body constitute a curious and highly interesting subject, to which I would now direct your attention. All living creatures whose existence depends upon the absorption of oxygen possess within themselves a source of heat, independent of surrounding objects. This general truth applies to all animals, and extends to the seed of plants in the act of germination, to flower buds when developing, and fruits during their maturation. In the animal body, heat is produced only in those parts to which arterial blood, and with it the oxygen absorbed in respiration, is conveyed. Hair, wool, and feathers receive no arterial blood, and therefore in them no heat is developed. The combination of a combustible substance with oxygen is, under all circumstances, the only source of animal heat. In whatever way carbon may combine with oxygen, the act of combination is accomplished by the disengagement of heat. It is indifferent whether this combination takes place rapidly or slowly, at a high or at a low temperature. The amount of heat liberated is a constant quantity. The carbon of the food being converted into carbonic acid within the body must give out exactly as much heat as if it had been directly burnt in oxygen gas or in common air. The only difference is, the production of the heat is diffused over unequal times. In oxygen gas, the combustion of carbon is rapid, and the heat intense. In atmospheric air it burns slower and for a longer time, the temperature being lower. In the animal body the combination is still more gradual, and the heat lower in proportion. It is obvious that the amount of heat liberated must increase or diminish with the quantity of oxygen introduced in equal times by respiration. Those animals, therefore, which respire frequently and consequently consume much oxygen, possess a higher temperature than others which, with a body of equal size to the heat, take into their system less oxygen. The temperature of a child, 102 degrees, is higher than that of an adult, 99 1/2 degrees. That of birds, 104 degrees to 105.4 degrees, is higher than that of quadrupeds, 98 1/2 degrees to 100.4 degrees, or than that of fishes or amphibia, whose proper temperature is from 2.7 to 3.6 degrees higher than that of the medium in which they live. All animals, strictly speaking, are warm-blooded, but in those only which possess lungs is the temperature of the body quite independent of the surrounding medium. The most trustworthy observations prove that, in all climates, in the temperate zones as well as at the equator or the poles, the temperature of the body in man, and in what are commonly called warm-blooded animals, is invariably the same. Yet how different are the circumstances under which they live! The animal body is a heated mass, which bears the same relation to surrounding objects as any other heated mass. It receives heat when the surrounding objects are hotter; it loses heat when they are colder than itself. We know that the rapidity of cooling increases with the difference between the temperature of the heated body and that of the surrounding medium. That is, the colder the surrounding medium, the shorter the time required for the cooling of the heated body. How unequal, then, must be the loss of heat in a man at Palermo, where the external temperature is nearly equal to that of the body, and in the polar regions, where the external temperature is from 70 degrees to 90 degrees lower. Yet, notwithstanding this extremely unequal loss of heat, experience has shown that the blood of the inhabitant of the Arctic Circle has a temperature as high as that of the native of the South, who lives in so different a medium. This fact, when its true significance is perceived, proves that the heat given off to the surrounding medium is restored within the body with great rapidity. This compensation must consequently take place more rapidly in winter than in summer, at the pole than at the equator. Now, in different climates, the quantity of oxygen introduced to the system by respiration, has been already shown, varies according to the temperature of the external air. The quantity of inspired oxygen increases with the loss of heat by external cooling, and the quantity of carbon or hydrogen necessary to combine with this oxygen must be increased in the same ratio. It is evident that the supply of heat lost by cooling is affected by the mutual action of the elements of the food and the inspired oxygen which combine together. To make use of a familiar, but not on that account a less just illustration, the animal body acts in this respect as a furnace, which we supply with fuel. It signifies nothing what intermediate forms food may assume, what changes it may undergo in the body. The last change is uniformly the conversion of its carbon into carbonic acid, and of its hydrogen into water. The unassimilated nitrogen of the food, along with the unburned or unoxidized carbon, is expelled in the urine or in the solid excrements. In order to keep up the furnace at a constant temperature, we must vary the supply of fuel according to the external temperature, that is, according to the supply of oxygen. In the animal body, the food is the fuel. With the proper supply of oxygen, we obtain the heat given out during its oxidation or combustion. In winter, when we take exercise in a cold atmosphere, and when consequently the amount of inspired oxygen increases, the necessity for food containing carbon and hydrogen increases in the same ratio, and by gratifying the appetite thus excited, we obtain the most efficient protection against the most piercing cold. A starving man is soon frozen to death. The animals of prey in those arctic regions, as every one knows, far exceed in voracity those of the torrid zone. In cold and temperate climates, the air, which incessantly strives to consume the body, urges man to laborious efforts, in order to furnish the means of resistance to its action, while in hot climates the necessity of labor to provide food is far less urgent. Our clothing is merely an equivalent for a certain amount of food. The more warmly we are clothed, the less urgent becomes the appetite for food, because the loss of heat by cooling, and consequently the amount of heat to be supplied by food, is diminished. If we were to go naked, like certain savage tribes, or if in hunting or fishing we were exposed to the same degree of cold as the Samoyeds, we would be able with ease to consume 10 pounds of flesh, and perhaps a dozen of tallow candles into the bargain, daily, as warmly clad travellers have related with astonishment of these people. We should then also be able to take the same quantity of brandy or train oil without bad effects, because the carbon and hydrogen of these substances would only suffice to keep up the equilibrium between the external temperature and that of our bodies. According to the preceding expositions, the quantity of food is regulated by the number of respirations, by the temperature of the air, and by the amount of heat given off to the surrounding medium. No isolated fact apparently opposed to this statement can affect the truth of this natural law, without temporary or permanent injury to health. The Neapolitan cannot take more carbon and hydrogen in the shape of food than he expires as carbonic acid and water, and the Esquimaux cannot expire more carbon and hydrogen than he takes into the system as food, unless in a state of disease or of starvation. Let us examine these states a little more closely. The Englishman in Jamaica perceives with regret the disappearance of his appetite, previously a source of frequently recurring enjoyment, and he succeeds, by the use of cayenne pepper and the most powerful stimulants, in enabling himself to take